Hello children, it's Sanjeev sir from Srimati LPSAVANI VIDHYABHAVAN, your statistics educator, welcoming you all to the class of statistics. Children, here we are going to see the standard deviation. What do we mean by standard deviation? Now, in our last lectures, we had seen the mean deviation. Mean deviation we had seen had been calculated with the help of the absolute measures, right? But to actually curb down the limitations of mean and mean deviation, standard deviation is used, right? So over here we are going to see what do we mean by standard deviation. As you talk about the higher studies, you would find that the standard deviation and the mean deviation are the most useful measures of dispersion that are being used. Here, while we talk about standard deviation is what? Standard deviation is the average of the positive root of the square of the deviation from the mean. I repeat, standard deviation is the average of the square root of the sum of the squares of the deviation from the mean. Here we shall see now the example number 12, right? It is related to the standard deviation. Let's read the question first. The runs scored by a batsman, okay, in his last 7 matches are given. Over here you would find the runs scored by the batsman, that is 52, 58, 40, 60, 54, 38 and 48. Okay, they have told over here find the variance of the runs of the batsman and also find the standard deviation. Children, over here we would see the variance as well as how to find out the standard deviation. Now for the variance you would find, while we talk about say the formula, our formula for variance, you would find that your variance is denoted by your h square, and it is actually your sigma into bracket x minus x bar whole square upon n. Similarly, as you talk about the standard deviation you always know is the square root of the variance, and that's why it is denoted by s. And as it is the square root, you would find the formula that s is equal to under root sigma x minus x bar whole square upon n. So as per the formula, what we'll do is that we are needed to find out the mean, okay, and as per the required formula we are going to just have our table prepared. So over here children, what we would do is that we would have all the runs which have basically been scored by the batsman, we will just write into the vertical order, right, and it is denoted by x. So you would find all the runs scored are basically written in the vertical order. All would be added because we need to find out the mean. Okay, the total is 350. Now we know while we talk about the mean, the formula for the mean is sigma xi upon n. Sigma xi is 350 divided by total number of runs scored by the batsman is 7, that is in 7 inning. What the batsman scored? It scored 350 divided by 7, that is 50 runs. And what is your 50? 50 is actually your mean. 50 runs is actually the mean, right? So over here now what we'll do, we are going to have x minus x bar, that is 52 minus 50 will give you say 2. So 58 minus 50 will give you 8. 40 minus 50 will give you minus 10. 60 minus 50 will give you 10. 54 minus 50 will give you 4. 38 minus 50 will give you minus 12, and 48 minus 50 will give you minus 2. What we need to do is that now we need to do the square, okay, of x minus x bar. So square of 2 you would find it is 4. Square of 8 is 64. Square of minus 10 will give you 100. Square of 10 will give you 100 again. Square of 4 will give you 16. Square of minus 12 will give you 144, and square of 2 will give you 4. What we need to do again? We need to have the total of it, and the total what we got is 432. Now to find out the variance, we saw the formula, that is the sigma x minus x bar whole square upon n. So sigma x minus x square had come up to 432. So 432 divided by n will give you 61.7143. We need to write the variance up to 2 decimal places, so it is 61.71. And as variance is the square of the standard deviation, you would find the unit that we write, that is also in square, right? So over here, children, again you would find that is the variance what we got. They had told us to find out the variance. Now about say the standard deviation, we have seen that the while we talk about say the standard deviation, it is under root sigma x minus x bar whole square upon n, right? So from above only, the we need to do only the square root of the variance. Okay, so the value of the variance we will put, we'll have the square root of it, and you would find the answer for the standard deviation is 7.8558. If we write up to 2 decimal places, it is 7.86 runs, and that is actually say the standard deviation, right? And as standard deviation is the absolute measure, we always write the unit for the same, right? Okay, here now we shall see our example number 13. What they given over here, that the time in minutes taken to solve a puzzle by 5 students are 5, 8, 3, 6 and 10. Okay, these are given in minutes. What they have told, that compute the standard deviation of the time taken to solve the puzzle. We need to actually compute the standard deviation over here. Now over here children, you would find these are the discrete values. We will see another formula to find out the standard deviation. Standard deviation is what? Over here you would find the formula for the standard deviation is under root sigma x square upon n minus mean whole square. I repeat, s is equal to under root sigma x square upon n minus x bar whole square, right? So over here children, you would find what we need to have, the table that we need to prepare is actually our x square. After x we need to prepare our x square. So over here, as it has been given, time has been given to us, so it's 5, 8, 3, 6 and 10. If we do the total of it, okay, you would find it is 32. This 32 would be used to find out the mean. Now for x square, you would find that the square of 5 is 25, the square of 8 64, 3 9, the square of 6 is 36, the square of 10 is 100, and you would find as you do the total of it, it is 343 234, and this we are going to use into our formula. So first of all, we'll find out the mean as it would be used into our formula of standard deviation. So while we talk about the mean, our x bar is equal to sigma xi upon n. Okay, sigma xi you saw over here, our sigma xi is 32, so 32 divided by 5 will give you 6.4, and it is actually 6.4 minutes as the unit been given, as the all the values which have been given were in minutes. So over here you would find the unit is in minutes and the mean is 6.4 minutes. The same thing we are going to use now into our formula of standard deviation. So over here, just we will see the formula of the standard deviation, and we will try to get the solution for the same. You would find, as we have discussed, that standard deviation is under root sigma x square upon n minus mean whole square. Sigma x square we have seen into the table, the total was 234, that we are going to put it over here, divide by 5 minus we found out the mean over here 6.4, right? The 6.4 whole square. First of all, we will do the we will divide 234 by 5. You will get 446.8 minus the square of 6.4 is 40.96. You will just deduct them first of all. It will give you 5.84, and as you will do the root of it, it is 2.4166. We need to write up to 2 decimal places, so our standard deviation is 2.42 minutes, and as again it is the absolute value, we need to write the unit for the same. Alright, so this is our 13th example where we have calculated, or we can say found out the standard deviation. Here now we shall see our next example, that is example number 14. What has been given in example number 14? That is the following are the closing prices the following are the closing prices in rupees of 5 shares. 5 shares are there, and over here they have given the closing prices. There is 132, 147, 120, 152 and 125. What they given? See the last line. Find the standard deviation by the shortcut method. Children, over here also we need to find out the standard deviation, but by the shortcut method. These are also the discrete values, right? Discrete values, as only the numbers have been given to us, only the share prices have been given to us. So by the shortcut method, if we talk about the formula to find out the standard deviation, you would find that it is your under root sigma di square upon n minus sigma di upon n whole square. I repeat, your s is equal to under root sigma di square upon n minus sigma di upon n whole square. That is the formula for the standard deviation by shortcut method when only discrete values are there, or you can say when only the values of xi is given to us. Right. Now over here, children, you would find for that what we need to do. We are having the prices. Now we are going to see to the table of it. Okay. What we need to do is that we need to have, as the prices have been given to us, right, we need to find out the division and then the square of it, right? So what will happen over here? To find out the division, we know that we need to have the assumed mean, right? And how we take the assumed mean? Assumed mean should be such a value, okay, around which all the other observations are revolving. Okay, assumed mean should be such a value around which all the other observations should be should be revolving. So over here, as the values given over here is 132, 147, 120, 152 and 125, you would find 135 is the appropriate value for the assumed mean. Okay, it's not like that you need to take 135 only. You can have 140 also or 130 also, but actually 135 is the appropriate one, because you will find all these given numbers are surrounding, or say are revolving around 135. Right. So over here you would find assumed mean, okay, has been taken up as 135. So what is our d? D is the deviation that what we are going to find out, and it is xi minus a. Okay, and what is our a? A is our 135. So 132 minus 135 will give you minus 3. 147 minus 135 will give you 12. 120 minus 135 will give you minus 15. 152 minus 135 will give you 17, and 125 minus 135 will give you minus 10. As you do the total of this, it will give you 1, right? That is the division that what we talked about, right? Then similarly you would also find that we need to do the square of it. So what is the square of minus 3? That is 9. Square of 12 is 144. Square of minus 15 is 225. Square of 17 is 289. Square of minus 10 is 100, and you would find the total of it is coming up to 767. And both these values we are going to use it into our formula, right? So now we will see how this could be calculated, right? So over here you would find into the formula, I will just zoom it out for you. All right, you will have these values, right, written. So this is a formula as we have discussed. For sigma di square, we have seen the total has come up to 767. Divided by what is the total number of observations? Total number of share prices given is total number of share prices which has been given is actually 5. Sigma di, we have seen the total has come up to 1. Divided by 5 again. Okay, whole square. So just solve it out internally. 767 divided by 5 will give you 153.4 minus 1 divided by 5. उसका आप स्क्वायर करोगे you will get 0.04. जैसे you will deduct it, it will give you 153.36. as you will do the root of it, it's giving you 12.3839, and as you write up to 2 decimal places, it is 12.38, and obviously it should be in rupees as it is the absolute value. So this is how we calculated our standard deviation. And children, as these are the discrete values and they had given that you need to use the shortcut method. This is the formula for the shortcut method to find out the standard deviation when only discrete values are given to you, right? So this is what we found out the standard deviation for the sum. Okay, now we shall see to the next sum, our example number 15. What has been given over here? the distribution of the number of the absent days of 15 students of a class in the month of January is given below. Find the standard deviation and the coefficient of standard deviation, right, of their number of absent days. Now children, over here we need to find out standard deviation and the coefficient of standard deviation. The interesting thing about the sum, you will find that over here the frequencies has also been given. Number of absent days are there, that is 0, 1, 2, 3 and 4, and number of days, and sorry, the number of students, that is how many number of students are absent for the given days. So over here you would find, children, that the frequency is also been given to us. Now as the frequency is given to us, right, now you know very well that when frequencies are given, it is our grouped data. It is our grouped data, right? So for the discrete frequency distribution, and when it is a group data, okay, the formula for our standard deviation, okay, becomes what? It's nothing. You need to only add f before our regular formula. Okay, you would find, while we talk about, say, the formula for the standard deviation, our formula for the standard deviation is under root, say, sigma fi into bracket xi minus x bar whole square upon n. I repeat, it is under root sigma fi into bracket xi minus x bar whole square upon n. That is, we need to have another additional column where we will multiply the column of frequency, and we will also multiply the column of xi minus x bar whole square, right? And we are going to take the summation of it over here into the calculation, right? Okay, fine. So we'll just move further. We'll just see how the table say would be prepared, right? Over here, children, into the table, you would find, first of all, yes, you need to write all the values first. So over here you would find you will have your xi, that is 0, 1, 2, 3, 4, right? It is your 0, then 1, 2, 3 and 4. That is your xi. Okay, frequencies are also been given to us. That is, you can say 1, 3, 7, 3 and 1. This is 1, 3, 7, 3 and 1. You will do the total of it because we need to have the mean. So the total is actually 15, right? So now we need to find out say fi xi, because when it is a group data, the formula for mean also becomes what? It is sigma fi xi upon n, right? So over here you would find the formula for the mean, that is your x bar is sigma fi xi upon n. So the next column that we need to have is sigma fi xi. So for that, what we need to do? We need to multiply fi and xi, right? So over here you would find 0 multiplied by 1 will give you 0, 1 3s are 3, 2 7s are 14, 3 3s are 9, 4 1s are 4, right? And as again we will do the total of it, it will give us 30. We are going to find out the mean for the same, that is 30 divided by 15 will give us 2 days. So what is the mean over here? The mean has come up to 2 days, right? Now xi minus x bar, alright, xi minus x bar. Now over here you would find, excuse me, over here you would find, as we'll do xi minus x bar, our x bar has come up to 2, right? So what we need to do over here is that is 0 minus 2 will give you minus 2, 1 minus 2 will give you minus 1, 2 minus 2 will give you 0, 3 minus 2 will give you 1, 4 minus 2 will give you 2. But we don't need actually the total of this, we need to have the square of it, right? So what we are going to do is that we will have the square of x minus x bar. Okay, we are going to do the square of x minus x bar. So the square of minus 2 you would find is actually 4. Square of minus 1 will give you 1. The square of 0 is 0. Square of 1 is 1. Square of 2 is 2 to the 4, right? Over here also, as we have seen the formula, we don't need the total of this, but this column, this particular column, we are going to basically multiply it by the column of frequency, right? So over here you would find that as we have the frequency, when as we have the frequency, right, you would find what can be done now. This frequency, okay, we will multiply by x minus x bar whole square. As you can say, 1 multiplied by 4 will give you 4. Say 3 1s are 3, right? Then 7 into 0 will give you 0. Say 3 1s are 3 again, and 1 4s are 4. Now we need to have the total of this. The total of this has come up to, that is fi into bracket xi minus x bar whole square has come up to 14. Right. Now this value we are going to use as to calculate the standard deviation, right, as it is for the grouped data. So I'll just zoom it for you. The value had come up to 14, right? So what we're going to have now, this sigma fi into bracket xi minus x bar whole square. Okay, 14 is there, so 14 divided by your n has come up to 15. So this 15 we are going to have the under root of it. First of all, you will do 14 divided by 15 will give you 0.9333. It will go on. As you will do the root of it, it will give you 0.9661, and as you write up to 2 decimal places, your answer would be 0.97. And as the unit was in days, okay, you would find it is 0.97 days. So the standard deviation over here is 0.97 days, right? And over here you would find they had also given us that they have also told us to find out the coefficient of standard deviation, if you remember, right? So that also we are going to see what is the coefficient of standard deviation. Okay, children. So over here, this is by another way, or you can say another formula is being used to find out the standard deviation. Okay, that also basically we can use. Okay, so you would find the formula over here. What they have used is under root sigma fi xi square upon n minus mean whole square. Now, children, just mark my words. Over here, while we talk about say fi, excuse me, as we talk about fi xi square, okay, what we need to do is not you are not going to do the square of the column of fi xi, but what you need to do is that you need to have say fi xi, right, multiplied by xi. Okay, you are going to multiply fi xi by xi to get what? To get your fi xi square, right? So over here it's fi xi square upon n. Now as you will do that, it will give you basically says the 74. Okay, if I talk about fi xi square divided by n is 15, and while we talk about the mean we had calculated, it was 2, right? So just you will just put it over here, right? You are just going to put it over here, put all the values, right? 74 by 15 will give you 4.9333 minus 2 2s are 4. Okay, you will just deduct first. It will give you 0.9333 root of it. You will get the same value, that is 0.9661, and if you write up to 2 decimal places, the standard deviation is 0.97 days, and days is a unit. Now while we talk about say the coefficient of standard deviation, okay, coefficient of standard deviation, the formula for the coefficient of standard deviation becomes s, that is standard deviation divided by mean. Okay, the standard deviation over here had come up to 0.97, so 0.97, and what we had seen, our mean was 2. So as you will divide it by 2, your answer is 0.485, right? So it is actually your 0.49. So what is the coefficient of standard deviation? It is actually 0.49, and you would find as it is our relative measure, you will not get any unit for the same. So that is our coefficient of standard deviation. So children, we'll stop our video today over here, right? Next time, in our next video, we are going to see the sums further, and we are also going to see the shortcut method, how it could be applied, and small technical things about the shortcut method that we are basically going to discuss, okay, into our next video. So for time being, goodbye, have a nice time, God bless you all, and take care of yourself and your family.